Hello everyone, this is Mukundan Raghavan, and in this video we are going to briefly discuss about MCP. MCP stands for Model Context Protocol. Before we start this discussion, let's understand ourselves. We might be the daily user who uses the LLM tools such as ChatGPT, Gemini, Claude, or GitHub Copilot for code editing. Or we might be the user who is integrating the different AI systems together. Even sometimes we are the ones who builds the AI system for our new business. In all these cases, you might have heard about the terminology called MCP, and this is a new buzzword in the AI world. What is this MCP? MCP stands for Model Context Protocol. But before understanding even detailedly about the MCP, we will try to understand how it came to the level of MCP. So we will start from the basic LLM, large language model. Yes, we all started any one of these tools such as ChatGPT, Claude, Gemini, or any kind of LLM. Initially, this is a simple content generation tool. For example, you will generate the new data, or you will summarize information, or you will translate. Basically, you will create some basic creative content. However, it had some constraint, which is these are confined to the training data. Whatever it was trained, based on that only it can give some output or it can generate some output. However, our new business or our actual context will be totally different. Even sometimes we don't want to provide everything into the prompt. So in those scenarios, we had to go to the next level, which is context. Yes, this is a very important step in the LLM world. For example, the context can be a file, simple PDF file, or it could be a database, or it could be Excel, or it could be a NoSQL database. Even sometimes you will not have the recent data. In that context, even it could be the browser search. So basically, we are giving some more information to the LLM to provide contextual output. And also, we had provided the memory to the LLMs, which means it will have more memory about our conversation so that you don't need to provide again and again the same information. So along with memories and the context, LLM became even more powerful. Now this is where it went to the next level, which is agentic AI. So far we have seen LLM has the generating capability and also it has been provided with context, even sometimes tools, memory. Because of that, LLM became more powerful. But still, these LLMs are reactive models, which means you have to be there to provide some inputs. And even though you get some valuable output, you have to do some action. Basically, LLM per se will not have any goal and will not do any actions. So that's why we came up with agentic AI, where LLM act like a brain, whereas other tools will do the actions. So that's where agentic AI became so popular. For example, it could send the mails, it could schedule the meeting, it could run the code. So based on our business context, we can do different actions based on our goals. Now, the real complexity came into the picture. You can see in the screen. Now, you have multiple LLMs. On the other side, you have multiple tools or multiple context. So being in the same topic, we can consider these tools are context. For example, your database, your code repository, your chat history, everything give more context to your LLM application so that it will give the close to precise output. However, our context became so many. As you see in the screen, it could be Slack, it could be GitHub, it could be SQL database, it could be local file, it could be cloud. On the other hand, we also have so many LLMs. Basically, we want to create the framework LLM agnostic. That means that we should not be dependent on or attached to only one type of LLM or only one provider for LLM. We should be flexible to switch between the different LLMs, also with the different LLM tools. So that's where we had a complexity because every LLM has to write the custom code to connect to the other context. And also, this LLM also keep on evolving and the tools also. So because of that, you keep on updating your code or writing the code to connect to the different applications. So this is where the actual MCP came into picture. The same discussion that we had about the integration challenge has been explained here. Now after MCP, MCP became an intermediate layer between your LLMs and the context. That's why it's a model context protocol. Basically, your models will connect with context with some standard protocol, which is nothing but MCP. Using this MCP protocol, you have seamless connection with the different tools. Basically, it provides a standard protocol so that you don't need to write a custom code for connecting every other context. So with this, we can clearly understand MCP is the standard protocol and it's not something like a special tool. However, this intermediate layer, I could say MCP server, has been built by the different vendors so that if you want to do some kind of connection between your LLMs and the different tools based on your requirement, you can connect with the MCP server so that you can easily integrate with other tools what you need. So by understanding the reason why we have to have the MCP gives us a clear picture to create a new AI application in the MCP architecture. So by this video, we have understood what is LLM and how the LLM has been evolved after adding the memory and the context. And also we have seen how it improved to the next level agentic AI, having goals and actions. Then we have discussed about the challenge when we have multiple LLMs and multiple contexts. So we had to write multiple custom code to have an integration. And we have seen MCP became an intermediate layer having standard protocol, which gives us options for the LLMs or models to connect with the different context. So that's why MCP, model, context, in middle you have to connect, the intermediate layer gives the protocol. So this is all about this video, and always be a rainbow in others cloud.